Alright, what we got today is more circle information, and there's a bunch of fancy names for these theorems and stuff that we're doing. I could honestly care less that you remember the names of these theorems, because it's not like we're going to do any proofs where we need to justify what we're doing. I just am concerned is, do you know what to do in these situations? So, as you can see here, where they're looking for this angle measure of x degrees right here. We got to ask ourselves the question, where is the vertex of this angle? My question to you is this the center of the circle? And the answer to that is we really don't know. It's pretty dang close to the center of the circle. It could be, but I really don't know because they didn't have a dot right there. So it's not like this angle right here is a central angle. We don't know that. So what we got to do is realize that this angle is not an inscribed angle either. An inscribed an inscribed angle's vertex is on the circle. We got to ask ourselves, or tell ourselves now, that this angle is inside the circle. If you can all just realize that angle's inside the circle, we'll be good to go. So here's what we got here. Would you all believe that these two angles right here are vertical angles, so they're equal to each other? Well, we're not really concerned about the vertical angles per se, but isn't this green arc right here contained by this angle x? And this arc right here is contained by this other red arc mark. So what I kind of call these two green arcs, I kind of call them vertical arcs. That's really not a term, I just made that up, but they're the arcs that are vertical to this angle x that they're looking for us to find. Today, real simple idea. Since the angle that they're looking for's vertex is inside this circle, we're going to take these green arcs measures and add them together and divide by 2. We're averaging these things together. So I can do that in my head. 162 plus 40 is 202, and then if I divide that by 2, that's 101 degrees. That's how simple that is. I didn't write any work down. I just did it all in my head or calculator. So you don't even have to write anything down for me. It's just add the two arcs together, then divide by 2, and then that's what that angle measure is. So we noticed again that this angle is inside the circle. That vertex is not the center. So when an angle's inside, you find it's the arcs that are contained by it vertically, and you add them together and divide by 2. So 200 plus 66 is 266. Divide that by 2. That's 133 degrees right there. As we move to the next problem, they're looking for this angle, which once again is inside the circle. So I need these arc measures in green right here. I do know that little guy is 20 right here, but this red arc now that I'll call it, I don't know it. So there's only 3 things you need to know. This angle, that arc, this angle, and this angle. Since I'm missing 2 of the 3 things, that really means that you should be able to figure out one of those. And we can figure out what this red arc is simply because the entire circle is 360 degrees all the way around, and this is the only arc that's missing. So if this is 60, this is 20, and this is 85, take 360 minus all those numbers, and you'll figure out how much this arc is. So please do that. That was 195 degrees. So now that I know this and this, since this vertex is inside the circle, I will add those 2 things together and get 215, and then divide by 2 and realize that that is 107.5 degrees. Don't forget the degree symbol. So there we go. Those first 3 were very, 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 very basic. You didn't know the angle measure. In this last one, we're going to require a little bit of work. Shown. We're going to have to show some work because once again we're dealing with these 2 arcs and this angle measure, but the thing is now I know the angle measure, I'm missing one of the arcs, so we're going to have to write some work down. We're just going to do the same process. Isn't the first thing that we're supposed to do is add these 2 arcs together? So let's do that. X plus 60. Then whatever that was, so it's like a quantity right there, whatever that was, we would divide it by 2. But instead of writing divide by 2, I'm going to do the other thing that's legal. It's the same maneuver as dividing by 2. I'm going to multiply that by 1/2. Okay, so we'll just put a half outside the parentheses. Then once I've added them together and taken half of that, shouldn't that always equal what that angle measure is? So that's going to equal 75. Is that all right? Add the two angles together, divide by 2, that's the angle measure. Okay, so let's solve for x now. Get rid of this ugly old half by multiplying both sides by 2. I'll show all my work since I'm not here today. And this times 2 and divide by 2 cancel each other out. And you're left with x plus 60 over here. And that equals 150. And now we could just solve for x by subtracting 60 from both sides and realize that x equals 90. Make sure we put that in the picture again. Sweet. All right. So angle inside the circle means add. You'll note in these next pictures, here's the angle they're looking for. There's its vertex. That is outside the circle. So if inside the circle means add them together and divide by 2, outside the circle is going to mean subtract them and then divide by 2. And hopefully we realize that this angle in red right here, like obviously since they tell you 84 degrees is bigger than 26 degrees, and you want to subtract the bigger number from the smaller number all the time, but notice this green arc right here, it's always going to be bigger than this blue arc because the red angle gets larger and larger and larger as it continues towards infinity. So this guy's always got to be bigger than that guy. So what we need to do is just subtract these guys from each other, 84 minus 26, and then divide it by 2. You don't have to show me any work right there, and that's 29 degrees is what that angle will turn out to be. Alright, so outside the circle means subtract, then divide by 2. Again, this guy right here, the vertex of what you're trying to find, is outside the circle, so subtract 120 minus 45. What is that? 75. Then divide it by 2 and get 37.5 degrees. No work necessary on those, but in this last one there is work shown that's necessary because what you're missing is an arc. So if you're missing the arc, we want to write some stuff down, and we need to do some subtracting since this vertex is outside the circle. The question is, which one's bigger? Well, x has to be bigger than 60 because this angle keeps getting larger and larger and larger, so you want to do x minus 60. Then divide it by 2. Don't forget you need to do that half of stuff all the time. That will equal the angle measure. The angle measure is always the dude by itself. The two arc measures are in the parentheses here, and don't forget about taking half of it all the time. So multiply both sides by 2. X minus 60 will equal 80. And you should realize that whatever you get for x has to be bigger than 60. Watch this. I'm going to make a mistake. X equals 20. Check out my mistake. My mistake was I subtracted 60 from both sides. And for those of you that really struggle at algebra, you think that you have to subtract everything over, subtract everything over, subtract everything over. Well, you don't do that in this situation. You need to add 60 to both sides and realize that x equals 140. You have to get a number that's bigger than 60 in this situation. So that's 140 degrees. Rock on. So let's try some homework-like problems. Please put this information in the picture. Here we go. AEC is 85 degrees. The picture makes things so much easier. Measure of arc BD is 95 degrees. It says what other arc measure can be found and what is its measure. Well, we really pay attention to the angle that they gave us. The angle is inside the circle, so we know this arc. Couldn't we also be able to figure out this one? So we could find the measure of arc AC. Alright, and I don't know it, so let's call it X. Since I don't know the angle measure, since I don't know the arc measure, I want to show some work. What should I do with these two arcs, though? Add them together or subtract them since this angle's inside? Inside means add. So X plus 95. Then you always need to take half of that, should equal the angle measure of 85. Solve for X. So put it in the picture, 75 degrees. Cool. Number 2, using the same picture but different information. So I'll go ahead and allow this. Let's just erase this information. You don't want to keep the same info and put new info in. So since they don't have the same picture more than once, we can erase, but that's alright. If the measure of arc AB is 144 degrees, and the measure of arc CD is 124 degrees, what is the measure of angle AEB, which is this guy? So these are the two arcs that are contained by that. That's inside the circle. So add those two things together and then divide by 2. And no work needs to be shown on that. 134 degrees is what we get. Sweet. What I would like now is for you to do just number 3 and number 4 with this information. If you'd please pause the video and allow the students to put that information in the picture and find 3 and 4's answers. So give them a second. Please pause the video and give them a chance to do this. Alright, so now that we're back, we knew this was 30 degrees, we knew this was 64 degrees. They asked me to find the measure of angle X, which is outside the circle. So outside means find the two arcs that are contained by it and subtract. 64 minus 30 is 34, and then divide that by 2 and get that to be 17 degrees. And then the measure of angle YUZ is right here, YUZ. That's inside the circle, so add those two things together and get 94 degrees and divide that by 2, and that's got to be 47 degrees. Number 5 says find as many other angle measures as you can. I don't care that you write them down. I really don't need that. I just want you to put it in the picture. I know it's a very small picture, but do your best to just put all the information you can find in this picture. You can find 7 more angles. So please pause the video and allow students to give this a try. The first and most obvious one is this has got to be 47 degrees because of the vertical angle theorem. And then from that you can realize that this angle right here has got to be 133 degrees because of those two are linear pairs, so that's a linear pair theorem. And then this is 133 degrees as well. Those should have been gravy problems. But there's 7 things to find. I've only found 3 things so far. And hopefully you realize that we want to start talking about like this. See this angle W? Isn't its vertex on the circle? And it's inscribed, so that means it's an inscribed angle. And isn't it inscribed, if you follow it all the way out, in that 30-degree arc right there? So that means that since angle W is inscribed in a 30-degree arc, that's got to be half as much of that. That's got to be 15 degrees. And you can do the same thing with angle V. It's on the circle, the vertex is, so it's inscribed in that same 30-degree arc. So that's 15 degrees as well. And if you want to roll with the other angle, angle Z could be found, it's on the circle, so if you, if you follow it out, it's inscribed in that 64-degree arc, so that's got to be half as much, 32 degrees. Or if you really, really wanted to, you see the triangle in the picture, you knew 2 angles, you could figure out the third angle by the triangle sum theorem. And then the same idea on this angle, it's inscribed in that 64-degree arc, so it's got to be 32 degrees as well. So there's the things we were doing. Now, true or false, are those 2 triangles right there congruent to each other? I'll give you a moment to think about that. Do we have enough information to prove that those 2 triangles are congruent? And the answer to that question is false. We cannot prove those 2 triangles congruent. The question is why? How do we know that there's not enough information to prove those 2 triangles congruent? Well, to prove triangles congruent, there's only 5 ways. Side, 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 angle, 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 side, and hypotenuse leg. In all 5 of these ways, you got to know at least one side length. I don't have any side lengths whatsoever in these 2 triangles, so they are not necessarily congruent to each other. What are those 2 triangles, though? Those triangles are definitely similar by angle-angle similarity theorem. It doesn't mean that they're not congruent. We just don't have enough information to prove it because we didn't have any side lengths. So kind of in this lesson I'm working some things out because we do have a final review, so kind of pay attention to some of these ideas just to refresh our brain. So that was a good one. Next one, suppose angle WXYZ is a rectangle inscribed in circle E. Inscribed means it's on the circle, so if it's rectangle WXYZ, that means the points W, X, Y, and Z are actually on the circle itself. So that's what inscribed means. If the measure of angle ZEW equals X, so X degrees, find these two things. Find the measure of arc ZW. I'm going to use red here and go back and call that X since it goes over the top. If that's X degrees, find the measure of arc ZW. I'll give you a moment here. Just pause for about 20 seconds and let's see if they can figure out what that is. Now that we're back, this was the important information. What's so important about this is it just says circle E. What does that mean about point E? Since it's called circle E and you name circles by their center, that means E is the center of the circle. So since E is the center of the circle, this angle ZEW is actually a central angle. And since this arc is contained by that central angle, if this measures X degrees, that bad boy's got to measure X degrees. That's it. It was a central angle. So we can't forget some of the basics. Central angle. Okay? So that was X degrees. To figure out the measure of angle YWX, let me find that and highlight it, YWX. I'm going to have him pause the video here and let's see if you can figure out what that is. So give him about 30 seconds to a minute to give that a try. Now that we're back, what we need to realize is where is the vertex of this blue angle? It's right here, which is on the circle. That vertex is on the circle, which means it's an inscribed angle. So if you follow it out and find the arc that's contained by it, it's this green arc right here. If we knew this arc's measure, that would be half as much of it. Well, we can figure out this green arc's measure because these two guys right here, aren't they vertical angles? If this is X degrees, this guy's got to be X degrees, and that's a central angle because E is the center of the circle. So if that central angle is X degrees, then the arc that's contained by it's got to be X degrees. So yummy! That arc measures X degrees. This angle W in blue is inscribed in it, so it's got to be half as much. So that's 1/2 of X degrees. Pretty neat? Alright. So that was that information. Now we get some new info, which I could really care less about, but they keep talking about the word tangent, which you've heard before with sine, cosine, and tangent. Tangent means something just a little bit different in this case, like a tangent line or a point of tangency. Here's what it means. This red line right here is not a tangent line to this circle for the simple fact that it intersects this circle in two places. To be a tangent line, you can only intersect the circle in exactly one place, which that is a bad drawing. Let's go down here. The blue line can only touch the circle in one place. If I call this point A right here, the blue line is a tangent line to the green circle because it only intersects it at one point. The point of tangency is just that one point A. The tangent line would be like the line AB right here. So that's what they mean by tangent. The thing is, they got all these goofy theorems and stuff like this that you're supposed to remember. I could care less about that. It's the same rules that we went through before. Okay, there's only 4 places of where the vertex of the angle could be. The vertex of the angle they're talking about, like this angle X, could either be on the circle, the center of the circle, inside the circle, or outside the circle. So this is the question we're asking ourselves every single time is, where is this vertex? Well, it's right there. That is on the circle. correct? So what we're going to do is we're going to treat this angle right here in green like it was an inscribed angle. Since the vertex is on the circle, we're going to pretend that that was an inscribed angle. And all I need to know is the measure of the arc that's contained by it. Well, isn't this red arc right here completely on the inside of that green angle? Since this is on the circle, use the inscribed angle rules of whatever the arc is. Take half of that, so half of 75 is 37.5 degrees. Because the vertex is on the circle, we treat it like an inscribed angle. In number 9, here's the angle they're talking about. Is it inside, outside, on, or the center of the circle? It's outside the circle, so that means we want to find the two arcs that are contained by it and subtract them. Outside means subtract the arcs. So I definitely got this red arc right here, which is contained by it. The other one is this blue fella right here. Well, there's three things you need to know. You need to know the angle, the arc, and the other arc. I only know one of those three things, which means I should be able to figure out the other one. And what you can figure out is the blue arc, because the entire circle itself is 360 degrees all the way around. The red part is one part of the circle. The blue is the rest of that circle. So if there's 360 degrees possible, that means that this has to be 70 degrees. Hopefully that makes sense. Now that you know these two arcs, since that angle is outside the circle, you're going to subtract and divide by 2 then. So 290 minus 70 is 220 degrees. Divide by 2, that means that angle is 110 degrees. Which is a horrible picture because that angle, the way it's drawn, looks acute, and 110 degrees is obtuse, but who cares about the picture? It's all about the proper mathematics. So let's try another one. This angle right meow, outside the circle, so I need the two arcs that's contained by it and subtract. I just don't know the green arc, but I can figure it out since it's the only arc measure missing. If that's 160 and that's 60, we could figure out that this is 140 degrees. Now find the measure of find x. Subtract. 140 minus 60 is 80, and then you got to divide that by 2 all the time and realize that that angle right there is 40 degrees. Groovy? Okay, in number 11, this is where I need you to wake up and pay close attention because it's kind of tricky. First, where's the vertex? Outside. Means you want to subtract. This is the green arc, which they call x. Here's the red arc. I don't know either one. I do know this angle. The question is, how much does the red arc measure? Well, here's how we can figure that out. Let's just pretend for a second that we did know what this was. If x was 100 degrees, would you be able to figure out how much that was? Sure, it should be 260 degrees, because isn't the red thing the rest of the circle? So I took 360 minus 100 to figure that out. What if x was 60 degrees? Couldn't we figure out that this should be 300 degrees by taking 360 minus 60? So the thing is, though, is we don't know what this is. It's x, but whatever this should be 360 minus x. And hopefully you realize that this red thing is bigger than the green one because of the way the angle's going. And you got to put 360 first because x is definitely less than 360. You always want to take big minus small. But this green thing's x. The red thing's got to be 360 minus that. Is just the basic rule. So that, honestly, isn't that difficult for people to understand once I've explained it. The thing that they struggle with is now, what do you do? Well, since the angle's vertex is outside the circle, we want to subtract those two guys, and we don't really do that very well. We get going a little too fast. Let me take the red guy real quick. I'll stay red. It's 360 minus x, and I need to subtract away this guy in green here. This guy is x, so I need to take 360 minus x and still take away x. Then once I've done that, I got to take half of that and set it equal to the angle, which was 30 degrees. So 360 minus x is the big boy. You got to take that away from the small boy, which is the x. So you really have this in parentheses. This is not very neat because inside of there there's some like terms. You have a minus x and a minus x. So you really have 1/2 times 360 minus 2x equals 30 degrees. And now we can solve that. So I'll multiply both sides by 2 and get 360 minus 2x equals 60. And then you should subtract 360 from both sides. I'm going to show all my work on this just for fun. Lots of fun. And people start freaking out when they do this because they're like, whoa, 60 minus 360, that's negative 300, which is correct. That's negative 300. But when these go away, what's left over there is not 2x, but it's a minus 2x. Watch that sign right there, and that's a big sweet relief because if you have a negative and you divide them, you should get a positive. So x itself equals 150. And now we can figure out this guy right here would have to be 210 degrees. Don't forget degrees, degrees, degrees. So that was a pretty neat problem. What I want you to do now is flip to the next page, and I want you to find everything that you possibly can. Don't worry about looking at the questions. Just find whatever you can, and here's where I'd recommend starting. Start by finding that green arc measure. And give them about, I'd say 2 to 3 minutes to figure out what they can here. And pause the video, and then we'll come back and go through it. So give it a pause. Alright, hopefully you realize that this was 80 degrees because this is a central angle. And then where you go from there, you got two choices. You could find this little guy right here because this angle's outside the circle and you have enough information right now to find it. Or you could have went blue here and found this guy right there. So that's where I want to start. I want to find the blue arc. The reason why I know I could find that is because this blue arc, it's contained by this blue angle where you do know this is 80 degrees and you know that's 30 degrees. So if we call that x, I'll set up a little equation. Isn't 80 got to be bigger than x because of the way the angle is opening? So I'll do 80 minus x. I got to take half of that and always set it equal to that angle, which is 30. Multiply by 2. 80 minus x equals 60. Subtract 80 from both sides. Negative x equals negative 20. And that means x equals 20. So this guy is 20 degrees. And then what you can figure out, like I said, is we can do this. This angle's outside the circle, so we do a little subtracting. 48 minus 22 is 26. Then we divide that by 2, and that's 13 degrees up there. And then the next thing we would need to find is, see this angle right here, I need this arc, which I got, and I need this arc, which I don't got. So what I realize is I'm missing 2 of the 3 things. The thing I need to be able to find is this arc. And I can do that because isn't it the only arc missing out of this entire circle, 80, 48, 22, 20, and 45? So we can realize that this arc now is 145 degrees. Then you could subtract these two and get 100 and divide that by 2 and realize that's 50 degrees. Now you can go back and answer those questions. Yep, only one more, baby. In the figure below, line CB and line CD are tangent to circle A and at B and D. So that means B is a point of tangency. They're basically telling you B is a point of tangency. That means that this line BE touches the circle in only one place, at point B. And same thing down here. D is a point of tangency. It says let the measure of arc BD equal x degrees. Please find, first off, measure of arc BDF. So BDF, this big boy, which we've already basically done most of this problem on a previous example. If this is x degrees, and this has got to be bigger because of the way the angle's opening, this has to be 360 minus x degrees. And make sure we're writing it correctly. If you have more than one term as an angle measure, you should put that in parentheses and put the x out or the degree outside the parentheses. So, and put it in the picture. It'll help us out. Next thing, part B says find the measure of angle ADC. ADC? What the heck? Angle ADC? They don't even have that drawn in there. So take your straight edge and let's connect A to D real quick. And we need to realize something special. Segment AD. What do you notice about segment AD? It's a radius, correct? It goes from A to D, center to any point on the circle. What's so special about D? D is a point of tangency. And what we need to realize that is if a radius intersects a circle at a point of tangency, this angle right here will always be 90 degrees. And let me prove that to you real quick. The reason why that's 90 degrees is because if this radius continued on to be a diameter, do you see this blue angle right here that they're talking about? Isn't the vertex on the circle? So we'll treat it like it's an inscribed angle. And you know this arc right here measures 180 degrees because that's a diameter, so that's 180 degrees. So that will be half of it, which is 90 degrees. So just something to remember. Radius touches the point of tangency, that will intersect the radius, and the tangent line will always intersect at a 90. Find the measure of angle BCD next. BCD, that's right up in here. What we're going to do is set up an equation to do that. And I can't use X because X is used all over the place, so let's call that Y just for fun. And isn't it true that since this is outside the circle, we want to subtract those guys? So here's what we'll do. I'll take 360 minus X. That's the big red dude. Take away the small one, which is X. And then I need to take half of that. And that should equal Y. Well, we're trying to figure out what Y is. Y is already all by itself on one side of the equal sign, but we need to simplify this a little bit further. So inside the parentheses, you can remember that that should simplify to 360 minus 2x equaling Y. But notice that there's still a number outside parentheses, and we can distribute that through. And it's nice that both of those numbers inside parentheses are even. You can take half of them really. So 180 minus x equals y. So that's how much that angle measures. 180 minus x degrees. And now I'm going to put that in the picture. That's 180 minus x degrees. The last question is, if I was in class today, I'd let you really try this for a while. But since we're not, I'll go through it. Find the measure of angle DCE, which is this dude right here. It has absolutely nothing to do with the circle or anything like that. But note these two angles. Is it not true that they are a linear pair? Right, so they should add together to equal 180 degrees. Like if this was 100 degrees, this red dude right here, shouldn't this be 180 minus 100, which would be 80? If this was 20 degrees, this would be 180 minus 20, which is 160 degrees. But what I want to do to figure this out, whatever that will be, it will be 180 degrees minus that guy, which is in parentheses 180 minus x. That's how much this angle measures. Thing is, that's not pretty because it needs to be simplified. There is a number outside parentheses. Most people don't realize that the number outside parentheses is a negative 1. So I can distribute this negative through. Let's distribute that negative through. Nothing happened to this guy. It's still 180. But distribute the negative. Negative 1 times 180 is negative 180. And negative 1 times negative x is a positive x. Now this has no more multiplication to do, but there are some like terms that we can combine. This 180 and minus 180 add together to be 0, so that just turns out to be x degrees. And hopefully you realize that 180 minus x and x add together to equal 180 degrees. So that was that. Thanks for paying attention. I know it was kind of long and everything, but I'll have the sub hand out the homework now, and you guys can go nuts the rest of the hour working on that. Work together. If you want to listen to your own music, you can, but make sure we're working. Thanks, and have a good one.